Hi, this is section 3.8, rewriting equations and formulas, and right now we're on we'll just start on page 184, and there's one thing we're not going to cover in this section, and that's called literal equations. If you look on page 184, you will see highlighted the term literal equations. We are not going to cover that. We're not going to test that. It's not a state of Michigan standard. All right. I have never, honestly, in all my years of math teaching, I've never really seen or used that much either. So no reason to cover that, but we will definitely be covering how to rewrite an equation and rewrite formulas. Okay? So let's talk about, when you look on page 187, if you turn ahead real quickly to page 187, you're going to see the following instructions on numbers 11 through 19. It's going to ask you to write the equation so that y is a function of x. And the first thing we got to know is, okay, what in the heck is that asking of us? When they ask us to write an equation so that y is a function of x, what does that mean? Okay? It means that we want to rewrite the equation so that y is by itself, or you're being asked to solve for y. Okay, do you remember early in the year, when I draw this picture, I know you'll remember it, we had the idea of a function being a box, and that you could put a number x into the function, and the function would produce y, and we could write a rule for it, like y equals, let's say, x plus 3. This rule would mean if I enter 1 into my function, the function would produce 4. If we entered in a 2, it would produce 5, and so on. Okay, this is function notation. Y is isolated. That's what they mean when they say write the equation so that y is a function of x. Okay, so let's actually do that process. Here would be an example, and this is where, again, thinking about the onion comes in handy. I want to solve this equation for y. Now think about this. This is just a normal equation like we would have done earlier in chapter 3. We would have to first, thinking about the onion, let me change my color pencil so I can draw up the onion. There's my inside layer is y, followed by the times 3, followed by the plus 6. I have to get rid of the plus 6 layer first. So I'm going to do that real quick. So just think about those steps. I'll take away 6. That gives me 3y equals 15. I'll take away 3, or divide, I should say. Divide each side by 3, and I'm getting y equals 5. I'm sure you're looking at that, and you're probably thinking, that's a piece of cake, so what's the big deal about today? Well, today, when you look at the problems like number 11, we're not going to be able to solve for y and get an exact answer. We're going to get an abstract answer for y. So we're going to do it the same way, though. Same steps. We're just going to have two variables in the problem. So step one is always write the equation. Now let's look at my onion. Y is the center. And remember, there's a plus outside of 2x. The plus 2x is the outside layer. To isolate y, I got to get rid of plus 2x. Well, how do I do that? Well, think about it for a minute. To get rid of plus 2x, I would have to subtract 2x. So I'm using the subtraction property of equality. These cancel. I'm going to get y equals. Now think about this. Can you take 7 and subtract 2x and get 5 out of that? I hope you're saying no, I can't, because they're not alike. All you can do is write 7 minus 2x, and there's your answer. You have rewritten this equation so that y is a function of x. Now, if you ask me what's y, I can't tell you the exact answer. Here's what I would have to say. Y would equal whatever 7 minus 2x would work out to. I can't give you an exact numerical amount. Okay? So you'll notice those steps look the same as before. Step 1, write the equation. Try to simplify it if you can. We use the subtraction property of equality, and I simplified it. Okay? Let's go to 14. Again, start off, I want to rewrite this so that y is a function of x. So I wrote the equation. Now let's think about my onion. There's the center. Center of the onion's here. Times negative 2 is the next layer. the plus 18x, remember I'm saying plus because there'd be a plus outside, the plus 18x is the outside layer. I got to get rid of plus 18x first. So I'm going to do that by subtracting 18x. So I just use the subtraction property of equality. Those cancel. I get negative 2y on the left. Now I cannot subtract 26 and 18x. They're not alike. So I'm just going to write it out as 26 minus 18x. Next step, I got to get rid of the times negative 2. So I'm going to use the division property of equality and divide each side by negative 2. Now, that means y equals 26 minus 18x divided by negative 2. But remember, this goes back last chapter, lesson 2.6. If you want to just quickly go back to page number, I'm going to pause here so I can get the page number. Lesson 2.6, page number 106. Let me just write that in. We worked on simplifying these on that page. And you might remember I said write these out as separate fractions. Let's do that. I got 26 over negative 2 minus 18x over negative 2. Let's reduce. 26 divided by negative 2 is negative 13. A negative divided by a negative is a positive, and 18x divided by 2, 18 divided by 2 is 9. This would simplify to y equals negative 13 plus 9x. So this is where it comes important, where, hey, stuff we've learned earlier in the year now is coming up again, where we have to simplify a expression with a fraction bar where I have two terms on top and only one on the bottom. Break it up into separate fractions. If you need to review that, go back and take a look at page 106. The problems number 33 to 41 were the list of problems for that, and this was one of our I cans back in chapter 2. I can simplify a fraction that involves a fraction bar and multiple terms. Okay? Let's do another one, number 18. Again, write the problem. Try to simplify each side if we can. I can't right now. I have to isolate y. So think about your onion. Y is the center. The times negative 4 is the next layer. That plus 11 on the outside is the outside layer. Okay, let's simplify. I'm going to take away my onion picture here real quick. I got to get rid of the plus 11 first. So I'm going to subtract 11. That's called the subtraction property of equality. Now, I subtracted on the right. That gives me negative 4y. On the left, when I subtract 3 minus 11, I can combine those together. That's negative 8 plus the 6x. Now I got to get rid of the times negative 4. So I'm going to use the division property of equality. I'm going to divide each side by negative 4. I get y on the right. Now, again, this takes me back to lesson 2.6. I want to simplify this. I have a fraction bar, multiple terms on top. I should break this quickly into separate fractions. I got negative 8 over negative 4 plus 6x over negative 4. Well, let me quickly simplify. Let me get that out of the way. Negative 8 over negative 4 is positive 2. Positive over negative is a negative. 6 divided by 4 doesn't work out evenly, so I'll divide both of these by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. I'm getting 3 halves x, and that would equal y. I just rewrote the problem so that y is a function of x. Okay? So really, we're not doing anything different than we've done throughout Chapter 3. It's just our answers are not going to be whole numbers or decimal amounts. They're abstract because I have two variables in the problem. Here's one more, number 19. I want to solve for y, so let's think about my onion again. Center, next layer, times 6, outside layer plus 2. I got to get rid of the plus 2 first. So let's get rid of that by subtracting 2. So I subtract 2. That's the subtraction property of equality. I get 6y on the left, and I have 3x plus 2. 4 minus 2 is 2 on the right. I got to get rid of the times 6, so I divide each side by 6. And here we go again. This takes me right back to lesson 2.6 where I'm circling right here. I have a fraction bar. I have to simplify this. So 3x over 6 plus 2 over 6 would be the way I can simplify it. Well, 3/6 is a half, so I got a half x, and 2/6 is a third. I just simplify that. This problem now, I rewrote the problem so that y is a function of x. Here's another just example here. Number 9, describe and correct the error. I want to solve this. It said, solve the equation for x. That means get x by itself. So, center of the onion is x. The next layer is times a. The outside layer is plus b. I got to get rid of the plus b first. So let me do that. I got to subtract b from each side. B minus b cancels. I have a times x on the left, and I have negative b on the right. Well, I can already see a mistake in the bookwork. They had positive b, so that's where their error is at. Let's finish the problem so we have it correct. To finish the problem, I got to divide by a. So I divide each side by a. This is a very abstract answer. I can't tell you what the numerical amount is, but x would equal whatever negative b over a would work out to. And then one more, or a couple more here. I'm going to skip 15. I think we've done enough examples of that for right now. But let's do 20. 20 is solve the formula for the indicated variable. This is a volume formula. I want to solve for W. Okay? So let's think about this real quick. I'm going to rewrite this. I can write this in any order I want because it's multiplication. So I'm going to think about it in this way. The volume equals the length, the height, multiplied with the width. Right? I can rearrange that, length and height multiplied with the width. So now think about the onion. There's my center. The length and height is being multiplied to the width. I got to get rid of that layer of multiplying length and height to width. So let me just erase my onion picture. That means I got to divide by length and height to get width by itself. So to get rid of timesing length height, I would divide by length height. And I would have W for width would equal volume divided by length height. Again, this is a very abstract answer. If you ask me what's the width of the problem, I can't tell you. All I could say is I know it's going to be whatever the volume divided by length and height work out to. Okay? This video has only been 13 minutes, so I tell you what, I am going to do number 15. I didn't want to make it too long, but I'm good on time here, so this one will only take me a minute. Let's solve for y. I want to solve this so that y is a function of x. So again, think onion. There's the center. Times 7 is the next layer. Minus 6x is the outside layer. So step 1, I have to add 6x. That's the addition property of equality at work. I'm adding 6x to each side. 14 plus 6x I can't combine. They're not alike, so I'm going to keep it like that. 14 plus 6x equals 7y. I have to get rid of the times 7, so I'm going to divide each side by 7. That's the division property of equality. I get y on the right. Now again, this takes me right back to lesson 2.6, which I've referenced several times on this video. I got to write separate fractions and simplify. I got 14 over 7 plus 6x over 7. Well, 14 over 7 is 2, and 6/7 I can't reduce, so I'll just keep it as 6/7. There's my equation where y is a function of x. So that concludes the video over this lesson. We can go over questions you have when you do the problems tomorrow.